All right, welcome back to Mr. P Helps with Algebra 2. This is Unit 2, Topic 1, SLT number 2. So we're going to get into using all the different types or all the methods for solving quadratic equations. Starting off with a practice warm-up on using square root method. Both sides are a perfect square, so I can do the square root of both sides. By perfect square, I mean this is squared, and 49 is a perfect square because it's a 7 by 7 square. 7 times 7, or 7 squared, is 49, so it's a perfect square. So anything, the square root of anything squared cancels each other out because they're inverses of each other. You're left with x plus 3 equals. Square root of 49 is both positive and negative 7. Now you might be thinking, why? So 7 times 7 is 49, but negative 7 times negative 7 is also 49. So there's two solutions. So you can then solve it twice, or you can move the 3 to the other side. So move the 3 to the other side, opposite operation becomes negative 3 plus or minus 7. And then you can solve it twice. So x is negative 3 plus 7 is 4, and negative 3 minus 7 is negative 10. Two solutions. Or set them, you can do negative 3 plus 7 on one side, or you can do x plus 3 equals 7, x plus 3 equals negative 7 on one side and the other, and solve it twice and get the exact same two answers. Alright, this one's also a perfect square. On the left-hand side, square root and squares cancel each other out. You're left with x minus 1 equals the square root of negative 16. So this is what we're going to lead to in the next couple of lessons, but for right now, we're just going to leave it the square root of negative 16 because we haven't done imaginary numbers yet. Move the 1 to the other side, and you get x equals 1 plus or minus the square root of negative 16. For the time being, we're going to leave it like this, and this is a complex number, which we'll talk more in detail in like 2 more videos from now. All right, so the point of this video is to show all the different methods, and when looking at a quadratic equation, to be identify which method is the best and when it's the best. And I'm going to show you an example of how to use all of those, but you can always go back to prior videos. This is just an example of different methods to solve the same problem. Gary did his wrong because he divided both by 3x minus 2, which in theory would work, but as you can see down here, it says by dividing both sides by the same amount, you're kind of eliminating that when it's equal to 0. So you're only getting one answer instead of getting two solutions like you should for any quadratic equation. Unless, okay, sometimes quadratics only have one solution, but it would have to be a perfect square in order to do so. These two would have to be the exact same thing. And they are not. Okay, solve the following using any of the methods discussed in class. So once again, going over them, I always look for factoring first. You can factor when there's a leading coefficient, but it's not going to be the easiest of all methods. 3 times 1 is 3. Actually, this is not factorable. So you multiply 3 times 1 is 3. What are the factors of 3? 1 times 3. None of those are going to add up to negative 5. So this isn't even factorable. It's not even on the table as an option. Come on, video. Move back. Okay, so that brings me to my next option, which will be completing the square. Well, anytime this is an odd number right here, or if it's not a perfect square right here, I'm just going to use completing the square. So that's going to lead me to quadratic formula. So negative b, so remember this is a, this is b, this is c. So quadratic formula is kind of my last resort because it's going to be a lot of work in order to solve. So that's negative b, b is negative 5, a is 3, b is c is 1, and b squared, so that's negative 5 squared minus 4 times a times c. All of that divided by 2 times a. Simplify this. The opposite of negative 5 is positive 5, plus or minus square root of. Finding the discriminant, I like to do it in 2 parts. Negative 5 squared is 25. Negative 4 times 3 is negative 12. Negative 12 times 1 is still negative 12. 2 times 3 is 6. Now I can simplify the discriminant. 25 minus 12 gives me 13. So 5 plus or minus the square root of 13 over 6. Now there's 2 different solutions, but I'm actually going to leave it right here because square root of 13 is not a perfect square. It's going to be an irrational number, and I don't want to round my answer. I'm going to be as specific as possible. So I'm going to leave it like that. All right, so that's my example of quadratic formula. If I come to another one's quadratic formula, I'm just going to kind of skip it. This one looks perfect. Perfect for factoring. What 2 numbers give me 12 but also add up to negative 7? No, it's not 12 and 1. That's not going to add up to negative 7. 6 and 2. Nope. And 4 times 3. And there it is. So it's negative 4 times negative 3. Negative 4 times negative 3, check. Negative 4 plus negative 3, check. Also works. So it's x minus 4 times x minus 3. And as I just stated, multiply them, you get 12, and add them, you get -7. Now I can set each one equal to 0 and solve. 0 product property. Anything times 0 is 0. So if whatever it takes to make this parenthesis 0, anything times 0 would be 0, and anything it takes to make this parenthesis 0, anything times 0 would also be 0. Answer here is 4, answer here is 3. There's your two solutions. All right, this one, perfect. This one's going to be square root method. I can easily make the left-hand side a perfect square, and the right-hand side's also now a perfect square. Perfect. Square root of both sides. Square root of anything squared is itself. Square root and squareds cancel. Square root of 25 is both positive and -5. Okay, this one I would have also done completing the square. Just move the 15. I might as well do it anyway. So x minus 3 squared equals -15, because when I move it to the opposite side, it becomes the opposite operation. In other words, I'm just subtracting 15 from both sides. Subtraction property of equality. Subtract 15 here, subtract 15. 0 minus 15 is -15. Square root of both sides, and there you go. Square root of anything squared cancels, and you get square root of -15. And just like we did on the warm-up, so I'm going to move this to the other side. I get 3 plus or minus the square root of -15. Now, this is going to be an imaginary number, 2 imaginary answers, because it's a negative square root. There is no real number multiplied by itself that ever gives you a negative. Once again, a couple videos from now. All right, so we've done factoring, so I'm really just looking for a completing the square question. So I'm looking for one right here. So, okay, this is a perfect example right here. So b divided by 2 squared. And what I'm looking for when I look at all these questions, I'm looking for when there's a is 1, so there's no leading coefficient. That makes it much, much easier to do completing the square. And I'm looking for a b term that's an even number. So 18 is perfect. So 18 divided by 2 is 9, so I don't have to deal with the decimal. 9 squared is 81. So there's two ways of thinking about this. This is already close to 81. So I could just say plus 1, add 1 to both sides, and that makes this 81. Or, if you don't want to think about what it would take to make that, because usually this number is not very close to b divided by 2 squared, move the number to begin with. So x squared, get rid of that c term, leave some space, so that makes this -80. And I want it to be 81, so I'm going to add 81 to both sides. And the reason I want to make 81, because that makes this side a perfect square of x plus 9. Why x plus 9? Because 9 times 9 is 81, 9 plus 9 is 18. -80 plus 81 is 1, and now I'm just going to basically do the square root method for the rest. X plus 9 equals both positive and -1. Move the 9 to the other side and solve it twice. -9 plus 1 is -8, and -9 minus 1 is -10. There's your two solutions. Okay, so just going through these. This is not factorable, so it looks like quadratic formula is going to be the best one for this one, because this is a b term is an odd number. For this one, clearly square root method, because when I divide both sides by 3, this is going to become 5, and now you've got a perfect square. So you can do square root of x plus 1 squared equals 5 and solve. For this one, I'm probably going to go with quadratic formula because I see this term in front. So that kind of eliminates, I probably could factor, so let's see, 2 times 8 is 16. Maybe factoring might not be that difficult and do the whole box method. Or quadratic formula there. Is anything equal 4? Actually, let me see if it's factorable first. 8 and 2, 4 and 4. Actually, it's not factorable because there's no factors of 16 that are going to add up to -4. So that's actually not factorable at all. So that's not even an option. You got to use quadratic formula. This one definitely square root method. Move this to the other side, makes this side 16, and then divide both sides by 8, which then makes this 2. So you get x plus 1 squared. I know I'm not really showing all my work, but I'm talking through it. And then I'll use square root method from there. This one, it looks like I would also do square root method. I would divide both sides by 3. That makes this a 7. And then you can take the square root of both sides. This one, I'm thinking probably quadratic formula. Two numbers that give you -7 also add up to 4. Yep, quadratic formula is probably going to be the best strategy for that one. And I might even go with quadratic formula for this one as well because of that 3 in the front. It's going to be a little bit more work doing factoring. All right, so that basically gets us through the lesson itself. So getting to the homework. This question is actually a fairly easy question. I can factor out the x on both sides. So that leaves me with negative 16x plus 350. So just by factoring out that x, made it into a simple equation that I can set each factor equal to 0. Well, that one's really easy. And then solve. Subtract 350 from both sides gives me negative 16x equals negative 350. Divide both sides by negative 16. I don't have a calculator right in front of me right at this time. I think you can handle doing the rest of that yourself. Clear annotations, of course, clear annotations doesn't work. All right, so the next question, number 6. Let's see. I'm probably going to go with, oh, by the way, this was factoring to find those two solutions. This one, 3 times 1 is 3. Well, are there any factors of 3 that adds up to negative 12? There isn't, so it looks like quadratic formula is my only choice. Negative b plus or minus square root of b squared minus 4 times a times c. All of that divided by 2 times a. All right, so the opposite of negative 12 is positive 12, plus or minus. Negative 12 squared is 144. Negative 4 times 3 is negative 12. Negative 12 times 1 is still negative 12. Divided by 2 times 3, which is 6. Okay, so 12 plus or minus square root of 132 over 6. And I'm going to leave the answer like this because this is an irrational number. 144 minus 12 is 132, and that's going to give you an irrational decimal. So I'm going to say just that's the answer. There are two solutions, 12 plus whatever this number is. It's going to be 11 point something, 11.1, 11.2, somewhere around there. So 12 plus that number or 12 minus that number, then divide by 6, and it's going to give you two different solutions. All right, so that is quadratic formula. This one I am going to multiply. Let's see if can it be factored. So two numbers that give you 80, but also add up to 20. 10 and 8. 10 and 8 would be 18. That's not quite it. Yeah, I think I might just have to go to quadratic formula on this one. So I'll set it up, but I'm running low on time, so I'm just going to set it up for you. So negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Okay, so that becomes negative 20 plus or minus. Let's see, I said I wouldn't do this, but I am going to go a little bit far into it. Negative 4 times negative 1 is positive 4. Positive 4 times negative 80 is negative 320. Divided by 2 times negative 1 is negative 2. Okay, so it looks like this is going to be the same case as this one. So it's going to be negative 20 plus or minus the square root of 80 divided by negative 2. And 80 is not a perfect square. So it does have two real answers. It's just square root of 80 is going to be an irrational number. So, and I don't want to round it, so I'm just going to leave it like that. All right. It's still not going to let me, of course. And last one, let's see. There is no b term. So if I move this number to the other side, so maybe square root method will be the easiest. Let's see, just divide both sides by, so that's 4t times 4t right here. So if I divide both sides by negative 1, that gives me 20 equals 16t squared. And 16t squared is really 4t times 4t. 4 times 4 is 16. T times t is t squared. So that's 4t squared. Sorry, I'm not sure why I didn't write it like that. 4t squared. All right. Equals 20. Then do the square root of both sides, and that gives me square root of 20 equals 4t. Divide both sides by 4, and there's your answer right there. So both positive and negative 20, square root of 20, divided by 4, because these two cancel, leaving you with just t. Okay, probably not the best method for that one. Maybe not, so maybe I can't factor it, so maybe quadratic formula would have been another option as well. But I'd already done quadratic formula twice, so I didn't want to do it again. And there I go. I have 30 seconds left. Thanks again for watching. Please give it a like if I helped you learn something about solving quadratic equations using various methods and identifying which method is the best. Awesome. Have a great day. Thanks again for watching.